Good afternoon, everyone. Let's wait for a few minutes until 3 p.m. Good afternoon, everyone. I hope you are doing well. So let's start or continue the class from the last class, that is thermodynamics. Okay. Uh, do you remember what we discussed in the last class? Right? We discussed what we ended up with internal energy. Right. Before that, we discussed what it was path function. This is what we discussed, right? Nothing but what is a system and what is a surrounding and what is the total universe called as. Nothing but we'll be taking surroundings plus boundary plus system is called as universe. But boundary is a imaginary wall between surroundings and system. So it is totally known as system plus surroundings properly. Okay. After these, we discussed many things on what happens if we increase pressure, what happens if we can decrease pressure, some things like that. And then we went to see what is intensive property, what is extensive property. Intensive means nothing but it is independent of the matter, how much matter is present inside the system. Extensive property is nothing but it depends on the matter, like how much matter. If we are increasing the matter, that means the extensive property which we are measuring will be also increasing or decreasing what we are doing based on that. In state function and path function, what happened? In state function, it only depends on final and initial step. That's it. It doesn't depend whether you are going to 100 kilometers run or 50 kilometers run. It will not be seeing that. Okay. It will not be seeing what path you are choosing to attain the final path from the initial. But in case of path functions, what happened? We'll be seeing how the initial and final state is attained, how the final state is attained from the initial state. The main thing you need to remember here. No. Your first question, that is 1 liter water has a density of 1 gram per ml. You all know that, right? If half liter of water is taken out from it, what will be the new density of water? You can pause the video and try it. No. Here, for 1 liter of water, density is 1 gram per ml. You know that, right? And he's saying that half liter of water is taken out from it. Now, what is the density of water? What is density? Nothing but mass per unit volume, right? Sorry, nothing but volume is nothing but, sorry, density is nothing but volume per, sorry, mass per unit volume. Now, even if you take 1 liter of water or 500 ml of water, what is the mass of the water molecules per unit volume is same. It doesn't change, right? So here it doesn't depend how much matter you are taking in on a whole. The density is not a extensive property, it is an intensive property. It doesn't depend on the how much amount of matter you are taking there. Clear, everyone? So here is the answer. You can note it down. Half liter of water will also have 1 gram per ml of density. Why? Because it is an intensive property. Density is an intensive property. But if you want to see mass, mass is an extensive property. As you increase the amount of water you are taking, if let's say 500 ml of water is there, it will be containing what mass? Let's say 500 grams of mass. But if you take 1 liter of water, it will be having 1 kilogram of mass. It is different. As we increase the matter, it is property is also increasing. That is called as extensive property. But density is an intensive property. It doesn't depend on how much amount of matter we are taking here. Okay. I think it is clear, right? It's a simple concept question, nothing more. Now, today we'll be seeing some concepts of first law of thermodynamics. And firstly, we'll be starting with our internal energy, where we left out. And then we'll go to law of conservation of energy and what is work and heat actually. And then we'll be seeing what is work and how we can do work, in how many ways we can do work, and what are the equations when we give it. We'll try to see. Okay. Now, first thing is internal energy. Now, if you remember yesterday, what is internal energy? Nothing but whatever the amount of energy stored inside a molecule. That is nothing but internal energy. Now, we know internal energy of many types, I said, right? Now, based on what we'll be seeing, based on degree of freedom, what a molecule is having, right? We have seen based on degree of freedom. That's what I said, right? Internal energy is nothing but energy stored inside a molecule, and on which properties that will be depending based on degree of freedom, nothing but we will be seeing all types of energies possible, maybe kinetic energy, potential energy, rotational, vibrational, all the energies will be seeing. Okay. No, yesterday we have seen delta U is equal to what? Integration of CV dt. We have seen this, right? No, first thing, what is internal energy? Nothing but whenever gas molecules in a beaker, they are colliding with the walls of the container, there'll be certain type of energy, right? Or let's say they are rotating around it, there'll be certain type of energy, or they are vibrating it, that will be having a certain type of energy. It also has a potential energy also, right? This all will be seeing. Now let's say translation energy, nothing but if, let's say if there is only one axis. Translation energy, there is x-axis and there is y-axis and there is z-axis. There is a molecule here, it can move along x-axis, along y-axis, along z-axis. All these axes are possible. Now let's say this is moving towards in x-axis, to and fro in x-axis. This is nothing but a translation motion in x-axis. It can move as well as in y-axis. It also can move in z-axis. So for any molecule, if you see, maybe monoatomic gas or diatomic gas, anything, generally it will be having 3 degree of freedom in translation motion. Okay. Generally, it will be having 3 degree of freedom in translation motion. Clear with that? No. After that, you can see as the molecule can rotate around itself, right? If there is a molecule, it can rotate around itself. That is nothing but rotational energy. And if you can see, the molecules can vibrate also. Slightly they'll vibrate, not totally. This is also a possibility where if we see in case of monoatomic gases, translation energy is monoatomic gases. Translational energy is 3. Translational degree of freedom, let's say. Translation degree of freedom is 3 for monoatomic gases. Okay. Let me erase this first. Highlight it here. For monoatomic gases, translation degree of freedom is 3. And for diatomic gases, for any gas, translational degree of freedom is 3. And now, if we see rotational degree of freedom, if we see rotational degree of freedom, for diatomic gases, it is 2. For monoatomic gases, it is 0. And for non-linear polyatomic gases, and for non-linear polyatomic gases, it is 3. Okay, clear with this? For translation degree of freedom, all the molecules can, it is possible to move along x, y, z and x, y and z direction. So it will be having 3 degree of freedom in translation motion. When we come to rotational degree of motion, monoatomic gases will be having 0 rotational degree, and diatomic gases or linear polyatomic gases will be having 2 degree of freedom, and non-linear polyatomic gases will be having 3 degree of freedom. Okay. Now, one more thing what we need to remember is of freedom. Vibrational degree of freedom. Now, in this also there is vibrational degree of freedom. In this also we'll be differentiating monoatomic, diatomic, and nonlinear polyatomic. In monoatomic, again vibrational degree of freedom is 0. Okay. Now, when we come to diatomic or linear polyatomic, linear polyatomic. Now, vibrational degree of freedom is nothing but 3n minus 5. N is nothing but atomicity of the molecule. Okay. Or if we go for non-linear polyatomic molecules, non-linear polyatomic molecules, the degree of freedom will be 3n minus 6. Okay. What is n? N is nothing but atomicity. Okay. Clear with that? Simple things. These you need to remember. Okay. No. Another thing you can see, due to these attraction forces between the nucleus or electrons, between the atoms, there may be repulsion set at particular time. There may be attraction at certain time. So based on this, again, they'll be having certain type of potential energy also. Force of attraction between the atoms and force of repulsion between the atoms. Both will be existing. Based on that, the potential energy of the molecule will be changed in a gas. Okay. Now, total internal energy is nothing but total kinetic energy, translation energy, rotational energy, vibrational energy, all these energies, and along with total potential energy of the molecule. Okay. Now, properties of internal energy. Depending only on the change in temperature of a system, the internal energy also changes. Do you know why? The only thing you need to see is, let's say you have taken a uh, gas, totally filled gas in a balloon, and like completely filled, a bulged one, and you kept it to a sunlight, and you are keeping it under magnifying glass. Now, what happens here? Heat will be absorbed easily, and the balloon, as it has a thin layer, due to some increase in the inside pressure, that increase in the inside pressure is due to increase in internal energy due to more collisions. As the temperature of the gas molecules increases, the collisions will increase from the molecules to the wall of the container. So because of this increase, the balloon will burst easily. Okay. Now same funda here. That is, as we increase the temperature, internal energy of the molecule increases and it will collide more. Okay. This is what you need to know. Now, just a simple normal thing. Let's say kind of small example to remember easily. Now, in winter, what you'll feel? You'll feel to sleep, right? More. And in summer, it is hot. You cannot sleep. So this is the same thing. Here also in gases or liquids, what happens? If we heat, what happens? Due to the increase in internal energy, the random motion will be increasing, right? The collisions will be increasing to the walls. As temperature decreases, internal energy also decreases. I hope you understood. If you have any doubts in this, you can enter in the chat, text in the chat. Now, internal energy is state function. Okay. It doesn't depend on you are taking 1 mole of gas or 2 moles of gas here. Okay. If you are having a particular temperature, the internal energy of the molecules will be, sorry. State function is nothing but it is not depending on how you are attaining the internal energy. Whether you are increasing temperature 10 degrees once, 10 degrees once, or you are directly increasing a 100 degrees centigrade in that. Okay. No, it is a extensive property. What does that mean? Extensive property means it will depend on the amount of matter you are taking. Okay. That means if you are increasing the number of moles, let's say you have taken a container. We have taken a container. Now let's say initially there is exactly 1 mole of gas. Okay. Initially N1 is equal to 1 mole. Now the collisions will be regarding with 1 mole only, right? The probability of collisions, let's say, we regarding will be with 1 mole itself. Now let's say N2, I'm increasing 1 more mole, that is total moles are 2 moles now. Now as the number of moles inside the container is increasing, but the volume is constant. Now at this point, what happens as the number of particles available increased, the collisions also increases. Because of that, again, internal energy will also increase. Internal energy of the particles will also increase slightly. Okay. It is represented with capital U. The SI units for internal energy are joules, energy units, right? Now, yesterday we have discussed this, right? Total U can't be measured, only delta U is measured. Why total U in a single point we cannot measure means because we need to add up a lot of energies to get only one internal energy term. So what we'll be doing instead of that, we'll be taking it as final internal energy is equal to U1 minus, sorry, U1 plus whatever heat we are providing or whatever work is done. That is nothing but if you are summing initial internal energy plus, or if we are providing some kind of heat to the system, that, or we are doing any kind of work, that if we combine all this, we'll get the final state of final internal energy of the system. Clear with this, everyone? This is nothing but if you send the U1 to other side, you'll get delta U is equal to Q plus W. Okay, simple. Now let's see law of conservation of energy. Sorry, we are have somewhat about internal energy system more, right? Let's see what is heat and work also in this, like how heat is affecting internal energy, how work is affecting internal energy first, and how number of moles of gas is also affecting internal energy will be seen. First thing, heat exchange between system and surroundings. Now, whenever this heat is exchanged between system and surroundings, let's say you have a gas here in a container, you have gas. Clear? Now what I'm doing, I'm heating it. What happens? There will be heat transfer from the burning thing to inside the system. Now, due to increase in temperature inside the system, what happens? The internal energy of the compounds will increase, where the collisions will increase. Clear with this? No. There is nothing but heat. If you provide it to the system, the internal energy of the system will be increasing. Work done on or by the system. That's a different case. Where we'll be seeing between pressure and volume. We'll be seeing that in brief way. Other thing, this is matter enters or leaves the system, nothing but number of moles. If you are increasing the number of moles, if you are keeping the volume constant, what happens? The collisions will increase because of that internal energy of the system will increase. Now, first thing, let's see heat exchange between system and surroundings. Okay, I think you can see this, right? You can see the GIF, what is happening. Now, initially we are taking the gas molecules and the gas molecules are in this way, right? Nothing but the gas molecules will be occupying the whole volume of the container. Yes or no? The gas molecules will be occupying the whole volume of the container, right? Now what I'm doing, I'm heating it. Okay. Now what I'm doing, heating it. Now, if I heat it, what happens? The molecular motion is increasing. Can you see this? The molecular motion is increasing. Now, as the molecular motion is increasing, what does it mean? Kinetic energy of the molecules increasing. Collisions are increasing because that kinetic energy of the molecules also increasing. Clear with this? This is nothing but increase in internal energy due to change in temperature or due to giving of heat, due to transfer of heat. In this case, the system is absorbing the heat. More kinetic energy means more internal energy. Don't forget that. More kinetic energy means more internal energy. The average kinetic energy of the molecules is directly proportional to temperature. Now here you can see heat and work are both forms of energies itself. But the only difference we'll be seeing here is, now if they are undergoing a random collisions, what happens? The internal energy or the heat inside the system will be increasing. Whatever the temperature we are giving, it will be used to increase these collisions. This is nothing but the energy is absorbed in form of heat if they are having random collisions. Now let's say they are all having in a particular direction. Then what happens? Let's say you have a wall container and a piston is fixed over it. Okay, piston is fixed over. Now whatever the gas molecules are there, let's say all are colliding above. What happens? They will be pushing the piston to above. Now what happens? This pushing of the piston towards some distance is nothing but work. Clear? Now in case of heat, what happens due to random collisions? The internal energy of the molecule is increasing, but no work is done here. No work is done by the system here. Now, in case of whenever we are giving energy to the system, this is heat is absorbed by the system, and then the work is done by pushing the piston due to the collisions at wind direction. These are two types by which a system can interact or can exchange energy with its surroundings. Whatever heat we are giving, and this is how they will be exchanging it with its surroundings. Not on this, nothing but heat when the energy transfer between system and surroundings takes place because of temperature difference. I said right, because temperature difference, what happens? Let's say we have kept a cold water bottle in hot summer outside in the surroundings. What happens? The bottle is the system. It will absorb the heat, right? Slowly the water molecules will become hot and hot. There is nothing but transfer of heat from surroundings to system. Next, work is nothing but any energy transfer which is not heat or which is not because of temperature difference is called work. Now, in case of pressure versus volume, what we did? Now, let's say what I'm doing now, I'm increasing the force from outside the piston. I'm pushing the piston inside it. Now, let's say this is V1. After pushing, what happens? After pushing, what happens? The piston will come somewhat lower. Now, this is V2. Now, what happens from V1 to V2? It is the volume is decreasing. Now, due to this decrease in volume, again, the collisions will increase as the available space is decreasing, right? This is also causing an increase in internal energy, but here there is no transfer of heat nor temperature. Clear? This work is different. Heat transfer is different. Work is different. Okay. Are you clear? If you have any doubts, you can post it in the chat. Okay. If you don't have any doubt, we'll be continuing with heat first. Thermal energy transferred from hotter body to colder body, right? You know this. Energy generated due to molecular motion within an object. Within an object. Okay. Now, heat is nothing but a transfer of thermal energy, and if we are changing the temperature, that is nothing but measure of degree of hotness and coldness of a system. If the temperature is high, that means if the body or the system is hot, that means internal energy of the system is high. The internal energy of the system is low, that means that the system is cold. Now, units of heat energy is joules, unit of temperature is Kelvin. Don't forget, whenever they give you any units of temperature and they ask you answers in temperature, then try to mention it in Kelvin itself. Only and only when they are mentioning it in degree centigrade, you mention the answer, you should mention the answer. then only you should mention as degree centigrade. Okay. If not, mention it in Kelvin itself. No, this is what will be happening from warmer. Let's see, you can see the color, right? Here it is reddish and here it is bluish, right? Now what is happening? It is heat is transferred from system to surroundings so that the heat will be dispersed out of the surroundings so that it will become colder and colder. Okay. If you heat the water, boiling water, if you keep it out on a gradual time, what happens? Gradually, what happens? The heat will be transferred from system to surroundings and it will come to the normal, whatever surrounding temperature is there, right? It will be like that. This is nothing but heat transfer. If you keep a cold bottle, nothing but it will absorb the heat from the surroundings and it will become somewhat hot until it attains the normal temperature again. Now, what are the sign convention we'll be using if heat is absorbed by the system or heat is entering the system? Okay, heat absorbed or if heat is absorbed by system, we'll give as Q as positive. Okay, if heat is going out of the system, that is heat is emitted, we'll be giving it as negative. Q will be negative if heat is emitted. If heat is absorbed by the system, Q is positive. If heat is emitted by the system, Q is negative. Don't forget this. If you are giving, nothing but you are losing, that is negative. If you are accepting, you are taking, that means it is positive. Okay. Now, heat exchange between system and surroundings, right? That's what we have seen initially. And then work done on or by the system, where pressure. Now we'll be seeing this briefly, work done on or by the system. Heat is done. Now, if you see here, what we have seen, here there is a stirrer, right? And we are using a weight so that we can, that will be pulling and the stirrer will be rotating. Now, as the stirrer rotates, what happens? What happens? The collisions, like the movement of the liquid will be increasing as well as the collisions will, the surface also will be increasing. Or if you rotate it very high, there'll be slight change in the temperature also sometimes. Okay. Work can be done in two ways in this way. First thing is you are doing the work in this way. Now, the same thing can be achieved by giving pressure on the gas. What happens if you are giving the pressure? This will be compressing and the number of collisions inside here will be increasing, right? Collisions will be increasing. Okay. Now, this piston is compressed so that there is no heat exchange. We are not giving any temperature or anything, right? What we are doing here, we are compressing the gas here. Temperature and internal energy is raised. Why? Due to compression of the gas, what happens? The collisions will increase. Now, what happens? Because of this internal energy increases and temperature of the system will be increasing due to more number of collisions. Here, we did not transfer any kind of heat. Here, what we did work due to pressure. Clear? After increasing pressure, what happened? The collisions increase, nothing but internal energy of the system is increasing because that temperature also increased. Now, here we'll be saying that what we can be concluding that is U is a state function. Now, we are doing different type of work in these two cases, but we are achieving the same type of change, that is internal energy change. Okay. How you are achieving the internal energy change is not the matter here. What we need to see whether you are having the final thing same or not. Okay. If you're, let's say you're changing the work by 1 kilojoule by doing this work and 1 kilojoule by doing this work. Now the change in internal energy will be slightly same, not different. This is about work done or on the system or by the system. Okay. Now work is done on the system, it is given as work is done on the system, it is given as positive. Work is done by the system, it is given as negative. Now next thing, as we discussed before, that what when if you are increasing the number of moles as the molecules are increasing, if you are keeping the container same, collisions will increase because that internal energy will increase. Now, Matter transfer into system. Nothing but if you are giving gas into system or you are removing the gas from the system. More number of molecules, thus leading to total increase in internal energy. Matter transfer from system. Less number of molecules, thus leading to total decrease in internal energy. As the collisions decrease, the internal energy of the system also decreases. Now, first law of thermodynamics. Are you clear until here? If you have any doubts, try to post it in the chat. Did you understand internal energy and how we can increase internal energy? One is by providing heat, or one is by doing work on the system, or one more thing is by changing the amount of matter in the system. By changing these three, we can change internal energy of a system. Clear with that? No. If you see, energy can't be created or destroyed. It can be converted from one form into another. The famous definition, right? First law of thermodynamics. Now, from here only we'll be having getting that is delta U. The other form what we have written, U2 final internal energy is equal to U1 plus heat transferred to the system or from the system plus W. Whatever the, like if heat is absorbed by the system, write as plus Q. If heat is given out by the system, write as minus Q. Based on that, you can change the same thing like work also, where Q and W are path functions, right? Heat is a path function as well as work is also a path function. Now, if you are climbing the steps through stairs, you are doing one type of work. If you are going through lift, the work is different. The work done by you is totally different. It is not same. No, the same thing in case of heat also. It is not same. Both are path functions. Depends on how you are achieving the initial and final steps. Okay. But in case of state function, that is delta U, which doesn't depend on the path you are choosing. It will only seeing whether you are attaining it. See, if you see in the formula also, if you are heating, or if you are, let's say you are keeping the work is constant and only Q is changing. Clear. Only heat of the system is changing. Even though the internal energy change, let's say you are keeping heat constant, that is Q constant, and you are doing some kind of compression or expansion work. Then their heat is not changing. The only internal energy is changing directly due to work done on the system or by the system. Doesn't depend whether you are doing the increasing the internal energy or decreasing the energy based on heat energy or work energy. It is not depending on the path which you are choosing. Okay. Why? That is the reason we'll call it as state function. If Q is equal to 0 as well as work is equal to 0, then only internal energy is 0. If you're not giving it heat or you are not absorbing the heat, anything is not happening, nor work is done on the system, then only internal energy will be 0. We can also say it as whenever this is possible, when delta U is 0, energy of an isolated system is always constant. Okay. Because it is not exchanging the energy. That is the reason we all call it as isolated system, right? We have discussed the types of systems, right? No. If you can do this problem properly, read the question properly and note down the given values first. Note down the given values first. I hope you are done. If not, let's see what is happening here. Now, express the change in internal energy of a system when no work is done on the system, but work is not done. He's saying, right? He's saying that work is not done in the system. What does that mean? That means W is equal to 0. Okay. But a Q amount of heat is taken out from the system and given to surroundings. He's saying that internal energy is nothing but what? Q plus W. He's saying that W is 0. That means what is the Q amount of heat is being taken out of the system. That means heat is emitted by the system. That means what we need to write? Minus Q. Remember that sign convention? Delta U is equal to change in internal energy is equal to minus Q. Now, what is asking? What type of wall does the system have? Now, heat is being exchanged. What we'll say? It is a open system or closed system. Which one? It doesn't say matter is exchanging, right? He said that it is The heat is being exchanged and there is no work done, only heat is being exchanged. Based on this, whatever it is given on the question, we can say it as system. See, you can note the answer once again. According to the question, W is 0 and Q is negative. That means delta U is equal to minus Q. Heat is flowing from system to surroundings. This is not isothermal wall, this is a conducting wall, right? Because that only heat can be transferred. As there is exchange of heat, so walls of the system are thermally conducting walls. Now, are you ready for a concept test? No. Tell me, neither Q nor W is state function, but Q plus W is a state function. Why? Simple reason, right? Can say that. Enter in the chat. Yeah, you are right. Nothing but Q and W are both are path functions, but internal energy is a state function. The only reason is even if you are changing a Q, internal energy will change, or you change only work, internal energy change in that way also. Whichever path you are choosing, the internal energy is not changing based on which path you are choosing, it is not changing. It doesn't depend on what path you choose. Even if you increase internal energy, even if you increase Q, internal energy will increase. Even if you increase only work, internal energy will increase in both cases. Right to note down. According to the first law of thermodynamics, you know that delta U is equal to Q plus W. Now, it is internal energy which is a state function because it only depends on initial and final steps, but doesn't depend on what path we are choosing. It will only see what is the initial internal energy, what is the final internal energy, nothing more. Whether you are increasing the internal energy with respect to work done on the system or work done by the system or heat absorbed or emitted by the system, it doesn't depend on that. It depends only on final and initial steps. Now, let's see work. Now, what are you seeing in front of you? Can you see anything? What is happening there? Yeah. You people know, right? There's nothing but a engine, car engine or something like that, or bigger engines, right? Where you'll be using petrol fuel or diesel fuel so that the combustion happens and the pistons rotate so that the wheels can rotate at last. Nothing but what we are doing, we are converting chemical energy into mechanical work here. This is also some type of work. What is happening here? The cylinder's volume is changing, right? The cylinder's volume is once it is decreasing, one is increasing. Whenever this is happening, the pressures also change. Whenever the volume is less, pressure will be high. Whenever the volume is high, pressure will be less. Because this change, this is simultaneously what happens. Because this, the combustion and all this happens, and the pistons goes on moving up and down. This is nothing but mechanical work. Now, only ideal gases are taken as a system just for our simple calculations. If you take a real gas again, there are a lot of complications. As you know, this is nothing but a PV graph. PV work, right? As pressure increases, volume P is inversely proportional to volume. Where did we learn this? In states of matter, right? In Boyle's law. As the pressure increases, volume decreases. As the volume increases, pressure decreases. The same thing in the pistons also. By using this kind of thing, we'll be moving the pistons above and down, below and at last, the work is done as wheels will be rotating. Energy exchange between system and surroundings against a constant external pressure leading to volume change of the system. Now, what is happening here? To keep the pressure constant, the pistons are moving above and below. That means one time compression is happening, one time expansion is happening. Both are happening. Right? Whenever compressions and expansions, why do they happen? Keep the pressure of the system constant. Right? These are the two works we'll be seeing in the piston. One is expansion work, one is compression work. Right? Now, if internal pressure of a gas is more, this is the thing, and let's say I'm taking a piston here. This red one is our piston, okay, airtight piston, and the gas is inside it. Now, let's say P external, that is nothing but the surrounding pressure, P external is less than P internal. What happens? The internal pressure is more, so that it will be pushing more from the inside, and the piston will be raised somewhat above. piston moves somewhat above. Nothing but what is happening? Expansion of gas molecules is happening so that the inside pressure will be constant whenever the piston is rotating. Okay. The first reason to expansion is to keep the pressure constant. And why compression happens? Whenever the energy is used up, again, what happens? Internal energy, internal pressure will be decreasing. So that again, what happens? Because of more external pressure, the compression happens. Clear with this, everyone? P internal is less than P external. Gas will compress due to external pressure. The same thing again will be taking the piston and this. Now, whatever the gas molecules which are pushing the piston are not having that much force. Then what happens? Due to increase in force of the external thing, what happens? The piston will go down now and it will move downward. This is nothing but compression. Whenever external pressure is there, the piston will go down and compression will happen. Whenever the internal pressure is there, in from inside, it will push the piston above and the expansion will happen. Derivation of expansion of work. What is happening? Pressure is being constant, but what is changing? The volume is changing. Okay. Now, if you see, this is the initial step, and after some expansion, dx volume will be increased or dx area will be increased. If you are heating again, we'll get one more dx. If you are heating again, we'll get one more dx. This is nothing but V1. V1, and this is our volume. Okay. After expansion, the volume increased here. Work is nothing but pressure into change in volume. What is the pressure? We are keeping the pressure constant and we are increasing the volume to keep the pressure constant. This is the work done on the system. Now, in expansion, what is happening? Due to increase in internal pressure, the piston is moving above. Now, what is doing? The system is doing work on the piston to meet above. Work done by the system, right? Pressure internal is nothing but gas pressure and pressure external. But if you are seeing atmosphere, that can say atmosphere pressure, or if you keep any weight on the piston, that will be that particular weight. Now, volume change is nothing but whatever this area is there into dx, which gives us the value of delta V, or we can write as V2 minus V1. Okay, initial volume and final volume. Final volume minus initial volume, it will give you the change in volume. That change in volume will give you the what is the work done by the system. If it is expansion, it is compression, that will give you the work done on the system. Okay. Force is equal to pressure external into area. Now work is done against external pressure, right? Now what is the against external pressure? What is the volume change? P external minus P external into now work done by the system, right? That's why we'll write it as minus P external into delta V. What is the change in volume? No, if P external into delta V, V2 minus V1. If it is expansion, that means V2 will be greater than V1. So obviously the work done will be negative. Work done will be negative in case of expansion. Okay, work done by the system. No, if we do compression, V2 will be less than V1 and W will be positive at that point. Derivation of expansion of work we have seen, right? Where W is equal to minus P external into delta P, V2 minus V1. Some noteworthy points here you can write it. Nothing but a negative sign in the final expression is only because to follow the sign convention of that, whether the work is done by the system or on the system. Just to know, we'll be writing. We'll not be saying that work is negative. Okay. Just negative represents that work is done by the system, and positive represents work is done on the system. That's the only thing. Nothing. Now, if process is done in various steps, then final work will be summation of all the single steps. Okay. Now, this is compression. What we are doing here, we are keeping the external pressure, we are increasing the external pressure so that the volume of the system is decreasing. If this is the volume V1, if this is the volume V2, what happened? V2 is less than V1 here. So that means what we'll get? The delta V will be delta V is equal to V2 minus V1, and this will be negative in compression. So as a whole, work will be negative into negative, right? Negative P external into delta V, where delta V is also negative. That gives you a positive work. What does positive work mean? That means work done on the system. Clear with this small change in the sign convention, nothing more. Formula is the exact same, formula is not changing. So work done on the system will always be positive and work done by the system will always be negative. This is called as PV work, pressure volume work. Hmm. Try to do this. Express the change in internal energy of a system when work is done by the system and Q amount of heat is supplied to the system. What type of system will it be? Try to see what is given first. He's saying that express the change in internal energy. He's asking to express delta U. He's asking us delta U is how much? When work is done by the system. If work is done by the system, what is the convention? Negative, right? It is negative. Work is negative. And Q amount of heat is supplied to the system. That means energy, heat is being absorbed by the system. Q is positive. Now, what type of system will it be? He is asking what type of system will it be? Delta U is equal to double Q plus W or W plus Q, same thing. And he's saying that W is negative and Q is positive. On a whole, what is the internal energy? What type of system will it be? Heat is absorbing as well as work is being done on the system. Note on the answer. Work is negative, right? And Q is positive. No, heat is exchanging, so it is will be a closed system. It doesn't say any molecules are escaping, right? If you ask about the walls, it will be a conducting walls. We'll be ending it for today, and next we'll be seeing types of works. Like in the next class, we'll be seeing types of works. If you have any doubts, you can text in the chat. Okay. If you don't have any doubts, you can leave the meeting.